Welcome to the deep dive. Today, we're looking at something pretty fascinating in plant health. Digging a bit deeper than the usual gardening tips.
Mm,
We're going to explore how the sugar levels inside a plant might actually be key to keeping pests away.
that's right. We're talking about Brix. Now, fruit farmers, they know this term well,
Right.
but understanding Brix, well, it can give us a whole new angle on why some plants seem to get hammered by pests and others just don't.
Okay, so our way into this is through Kesser and Steen, their students, right, in Mr. Hendrick's Nature and Innovation class.
Yes, and their teacher invited this insect expert, Tom or Thomas, to come talk.
And what's really interesting about Tom, this expert, is that he's got a PhD affiliated with Cornell even, but he's focusing on, well, measuring sugar breaks in leaves. Seems a bit different for an entomologist.
It definitely is a bit of an unconventional path compared to, say, just studying insecticides or pest behavior directly. What's compelling is his focus on the plant's internal state, this sort of sweetness factor, rather than only looking at external threats or poisons.
Exactly. And that's really what we want to unpack for you today. Our mission, if you like, is to get a handle on this core idea, Brix, and how it links up with pest resistance in plants.
Think of it as the essentials, a shortcut to understanding this concept without getting bogged down in, super technical stuff.
Okay, let's get into it then.
So this idea of Brix, where does it really start in this context? Well, Kesser and Steen learned it's something fruit farmers are really familiar with.
Right, like for apples, grapes.
Exactly, cherries too.
Yeah.
They often get paid based on the sugar content. It's similar to how dairy farmers are paid based on protein and fat in milk. It signals quality.
That makes total sense for fruit, obviously. Sweetness means ripeness, quality. But the source material makes this interesting comparison, doesn't it, between that and modern farming?
It does. It contrasts like a cow feeding its calf naturally direct. Milk quality meets the need with modern dairy.
Where cows are often housed, fed specific rations.
Precisely. Farmers calculating feed units, protein, optimizing for production for the industry, a bit removed from that natural feedback loop.
And that's where Steam pipes up with a pretty sharp point, connecting this to crops and, well, the economics of it all. He basically asks, are we pushing for cheap food at the expense of the plant's own health, its own resilience?
It's a really valid question. Is there a trade-off between quantity and, let's say, inherent quality or robustness?
Yeah, it makes you think about our whole food system approach.
And from there, the material guides us back to the plant itself, to the basics, photosynthesis.
Right. So plants use sunlight, make sugars in their leaves. That's their energy, their fuel.
It powers everything they do.
And the point being made is if a plant isn't making enough sugar, well, its overall health takes a hit.
Think of it like this. A well-nourished plant, brimming with these energy-rich sugars, it's like a fit person, right? Much better able to handle stress, including pests.
So that brings us back to Tom and his core idea connecting these sugar levels measured as Brix to pests.
Yeah, so Brix basically, for our purposes, measures dissolved solids, mostly sugars, in the plant's sap.
Okay.
And Tom's hypothesis is that low Brix often goes hand in hand with pest problems, like aphids, not because the plant is missing some sort of poison,
No.
but because it's just less vigorous, less able to, put up a fight.
That really flips the script on how we usually think about pests, doesn't it?
It does.
Instead of just reaching for the spray bottle, it suggests looking inwards at the plant's own condition.
Boosting its natural defenses. Now, the source does nod to the fact that Brix is technically more complex than just sugar.
Right. Nuances we're skipping for now.
Exactly. We're keeping it straightforward today, but it's worth noting Tom's credentials. PhD, Cornell. It lends a certain weight, especially when exploring a less common angle in entomology.
Studying Brix and leaves, it shifts the focus, doesn't it? Away from just killing the bug.
Towards understanding the plant's internal environment, what makes it attractive or resilient in the first place.
Which kind of neatly leads us to Tom's observations about ants. Apparently, he spent a lot of time just watching ants.
Yeah, trying to figure out why they're so drawn to aphids. The analogy used is like an experienced person, maybe an oma, knowing fruit sweetness just by taste.
A natural feel for it.
Exactly.
Yeah.
And ants themselves are fascinating. They farm aphids for that sugary honeydew.
Right, they milk them.
Some even cultivate fungi. They have a big ecological role, even if we find them annoying in the garden sometimes.
Definitely. Now, Kesser and Steen, the students, they react a bit differently here. Steen's thinking very practically.
Yeah, he wants to know, okay, how can I measure this Brix in my kitchen garden? How do I use this to stop aphids?
He wants the tool, the method.
Whereas Kesser, he's digging deeper into the why, the biochemistry, the physiology behind it all.
Wants to understand the mechanism.
Understand the root cause, yeah.
And Tom gives them a key number, a sort of benchmark. He's observed that aphids seem to steer clear of plants with Brix levels above, 8 or 9 degrees BX.
That's the range he mentioned. Now, what that means can vary a lot between different plants and their growth stages.
Sure.
But generally, hitting that 8-9 degree ABX range often suggests a healthier, more robust plant. Think of it like a threshold.
A threshold for defense.
Yeah, where the plant likely has enough energy stored up to activate its own defenses if needed.
Which connects to that idea of plant communication and energy reserves. The source talks about plants signaling when they're attacked.
Right, but they need the energy tied to sugar production, hence Brix, to actually do something about it.
To open that toolbox of magical components, as the source puts it.
It's a great analogy. That toolbox contains things often called secondary metabolites. They aren't for basic growth, but for defense, attraction, that sort of thing.
I see. So good energy reserves, good Brix, means the plant can actually use its defenses.
It's better equipped, absolutely.
And then there's this observation about butterflies in cabbages. Tom suggests butterflies might actively seek out weaker cabbage plants.
Yeah, plants that maybe aren't producing those defensive secondary metabolites effectively makes them an easier target for the caterpillars.
That's fascinating. And Kesser picks up on this immediately, asking, could butterfly eggs then be an early warning?
Like a signal that the cabbage plant itself is struggling.
Exactly. It's a really sharp observation.
It really highlights Tom's approach, too. He's clearly very data-focused.
The researcher type.
Definitely. Loves his numbers, uses a digital refractometer nicknamed Teddy, apparently.
Teddy the refractometer.
And meticulously records these Brix measurements. The end goal, healthier plants, fewer issues, all by improving sugar production.
Which then prompts Kesser's gorilla buffet thought. Can we learn by watching how wild herbivores choose their food?
It's a great question. Are there natural indicators of plant health that gorillas, for instance, instinctively recognize, things we miss?
Food for thought, definitely. Now, okay, if a plant is struggling, low Brix maybe, the first instinct for many gardeners is fertilizer.
Reach for the NPK.
Right. But Tom warns against going heavy on nitrogen, those N-rich formulas, and chemical fertilizers in general.
Yeah, he points out they can be quite high in salts, essentially. And that saltiness can actually harm the soil biology.
Disrupt the balance, like too much salt isn't good for us either.
Exactly. It's a crucial point. We often see fertilizers as just good, but they can have downsides, especially for the soil ecosystem.
And his caution extends to pesticides too, doesn't it? Herbicides, fungicides like Roundup.
He argues they also damage those beneficial soil microorganisms, the ones we actually need for healthy plants.
He even mentions that spray damage, say from Roundup, can sometimes look like salt damage on the plant.
Which reinforces that idea of disrupting the system, harming that delicate soil life.
So it sounds like there's no single magic bullet here, no quick fix.
Not really. But Tom's suggestion is that tackling low Brix by improving how the plant is nourished, that could be a fundamental part of the solution.
Which leads right back to Steen's practical question. Okay, if we're cautious with traditional fertilizers, what should we do? What are better approaches?
And the answer seems to point firmly towards the soil itself.
Right. The source really stresses the role of soil microorganisms. They're the ones making nutrients available to the plants.
They're like the crucial middlemen, breaking down organic matter, unlocking minerals. So focusing on soil health, building up organic matter, supporting microbial life that can naturally help plants increase their Brix.
So you might need less focus on just hitting specific NTK numbers on a bag?
Potentially, yes. It's about creating a thriving soil environment that supports the plant's own ability to make energy and defend itself.
Interesting. The source even threw in that bit about table sugar.
Oh yeah, that was surprising. Apparently, adding a bit of simple sugar can give soil microbes a temporary boost, which can briefly bump up Brix.
Just a short-term jolt, though.
Not a long-term strategy, but it illustrates the principle of feeding the soil life.
Which reminds me of Kesser and Steen's observation about those wild apple trees.
Ah, yes. Growing in a meadow, looking perfectly healthy, no pest issues.
Just doing their thing. And Tom apparently got really excited by this.
Immediately wanted to go measure their Brix. It's a perfect example of looking at nature, at what works in a balanced system.
Absolutely. And, this hints at something deeper, too. The source mentions genetics briefly.
Right. Different plant varieties, like different grape types for wine, naturally reach different Brix levels. They have different ripening times, different potentials.
So it's not just about the growing conditions. There's an inherent factor, too.
It seems so. There's a baseline capability, perhaps, linked to the plant's genetics. Physiological maturity plays a role, too.
Which raises a really interesting question to chew on, doesn't it?
Definitely. Why do these inherent differences exist? What makes one variety naturally higher in Brix, potentially more resilient in this way, than other?
It's a really thought-provoking point to end on.
It is. So wrapping up our deep dive today, the main takeaway is that understanding Brix, this measure of dissolved solids, mostly sugars, it gives us a different lens, a way to think about plant health and pest resistance that's more about internal vitality than external warfare.
It feels more holistic, maybe. Focusing on the plant's strength, drawing on insights like Tom's and observations like Kesser and Steen's.
Yeah, we've seen how it connects photosynthesis, energy, soil health, and even snack behavior.
So as you think about plants, maybe in your garden, maybe just conceptually, we'll leave you with that final question. What's behind those genetic differences in Brix potential? What makes some plants inherently bigger equipped in this way?
Lots to consider there. Thanks for diving deep with us today.